There's a couple of reasons why I didn't go live last night. Number one, it's just everything gets done after a while. So, and there was another reason. I was having a bit of a brainstorm last night. I was working some stuff out, and it kind of really hit me a little bit about what the next phase would be. Ooh, helicopters flying around outside, I think. Ooh, look at that. Cool. Lost it now. Yeah. So where was I? People have got a bit lazy, and obviously there's probably a crap time on this, right? So last night I came up with some ideas to improve the output and triple it basically, and I was also thinking about how much this is costing me with wire. Let me just bring it over here a minute. Oh yeah, I but I actually put this in. I was so tired and I didn't feel like talking. And it's a good thing I didn't go live, because I had some problems with the segments. I had actually accidentally got acetone on the rotor, and some of the segments were stuck and I couldn't get them out. So I was fighting with that with a knife, trying to get between the segments and the rotor for about half an hour to an hour. And that's after I woke up, like, you know. So I got the segments out and put the new ones in. And so what I was thinking about last night was doubling the rotor, so that the rotor is put two rotors back to back, so that instead of it being that wide, it'll be that wide, or triple it with 3 times as wide. The reason for that is then I can get more wire over a wider area. Instead of being just confined to this small area here, we'd have wire all the way to. That would use a lot of copper. That would use quite a lot of wire, and excuse me. So I had to go out a bit ago because it was day to sort bills out and everything. So that would effectively give me more surface area for the magnetic flow, and the only thing about that is I would need where's my drawing? Where's the other drawing gone? Can't find it. Can't find the drawing. The one I want. Trying to find the right one. Such a lot of clutter around here. I don't think I've got the drawing around here. I'll have to go into 3D model, actually. It'll be easier if I just go into 3D model. Right, just give me a second. I've got to get the model up. I'm going to give me a minute. I'm trying to get the stand out. I'll take this cover off so I can get it on the stand. I'm trying to avoid pressing these silly buttons that I seem to keep doing and then resetting my phone, which is a bit of an annoying disaster. Right, so if I can just get this up without pressing any buttons. Come on, don't go and press many buttons. Right, okay. Right, so I'm just going to stick my phone. Actually, I'll leave it here because then I can just zoom in. So let me just zoom in again. That's probably a better zoom in. The audio doesn't stand around. It's been awkward. Right, let me just get that on. So right, let me just go up to the rotor. Let me copy this rotor. Let's copy that rotor assembly. I'll show you why in a minute, because I want to flip that over. Hang on a minute. Right, just pick a surface. I need this surface over here. It's vertical. Hold my shift key down a minute. Shift keys hold down. Go over here. Oops, pick that corner. Right, I should be able to rotate this whole lot around now. Right, I want 90 degrees. That's 90 degrees. So those, no, it hasn't. So copy that rotor. Let's just do the back-to-back idea. If I press my control key down and hold my shift key down, I'll leave a gap between them. Then if I flip that, what axis are we on? What axis are we on? Oh shit! It's not even on a axis properly. I don't think. Hang on a minute. Select that. I'll just move all of that lot over here, because on an axis. Stick it over here. Oh, it looks like it is on the green axis. That's good, right? Okay, good. Otherwise, when I flip it, it'll be cockeyed. Right, edit group. Right, select that one. Flip along. Green. You can't. Oh, actually, that hasn't done anything. What the hell? What? Flip along. Green. Groups green. Oh shit, it's not working. Alright, so is it red? Flip along, groups red. What the fuck, it's not working. What the hell? It must be the blue axis. Oh Jesus. Flip along. Blue axis, that's done it, right. Yeah, the group has got a different axis built basically, so that's causing me some confusion. So what I was thinking about last night was having two rotors basically back to back like this, and building a bigger unit. But obviously I would have to use the segments from, I'd have to make more segments. But the good news is the old segments, well, the segments I took out, I actually only lost, well, the old segments which I swapped out versus the new segments, I actually gained about 0.7 volts. But by having this, by having two rotors back to back, making the canopies twice as big, I would gain a substantial amount more output, more voltage, which means and less wire would be folded around the back of the canopy. If I just leave that there a minute. So at the moment, the wire is wrapped around the pegs on here, the purple or the pink and the green. So the wire's wrapped around these pegs, right, and it goes down the side, and the coupling on the side of these canopies is pretty bad really, because we only the segments if I go to the actual assembly itself, which is over here, and I go to X-ray view, if I put X-ray view on, like that, now the pegs where I wrap the wire around, I'll just turn it up a minute, it's here and here, right? So these two, put X-ray back on, so you can see that the actual wire on the side is only halfway across these segments, right? You see, the wire comes down, it's wrapped around these pegs, and it goes back. So if you look at this point here, keep moving it, you'll see here on the side, the rotor assembly is over about, well, it tends to fill out a bit this way anyway. When you wrapping more wire, it starts to fill in and come closer to this edge anyway. But we're actually losing some of the power there, because there's a huge gap. If you look between the canopy surface, which is this edge here, right, the canopy surface there, we have a massive gap between the canopy surface and the segment. So we haven't got coupling to begin. Come down, turn X-ray back on, back off again, because I want to get to about here. We have 12 frigging millimeters. No, 11 millimeters, right? We have about 11 millimeters of space between the coil on the canopy surface and the actual segment, right? That's to the rotor. So you think that's a massive waste of thinking about that to try and we get better canopy. Really massive gap here between, I mean, we've got the thickness of the canopy itself, we've got the thickness of the I'm getting messages from someone. Oh, it's my friend Dave. So I've got this huge 12mm gap really between the surface of the, this is this edge here, down to the segment. I mean, that's 8.8 millimeters down from the edge of the canopy down to the rotor. So I can close that gap up a bit on the canopy area. I could shrink that down a lot. It means redrawing it, remodeling it, and I thought, well, rather than just doing that now, which is kind of surplus to requirement, I should say, because what I really want to do is make the rotors wider so that we can have a bigger surface area. So I might as well kill two birds with one stone. So when I redesign this, when I make this wider, I did say right from the outset, right from the very beginning when I started designing this thing, that this was a test jig. It's to test out the theory, to determine whether or not it's feasible and everything or not. And so far, it's been proving itself really well. I mean, it's been demonstrating a lot of promise. Because when I do these tests, I mean, it basically, I haven't really noticed a significant amount of drag on it. And that is because of the way the rotor is because it's not permanently magnetized like a conventional magnet rotor would be. So it basically changes state as it's rotating. We have two equal opposite reactions going on which cancel each other out. So that basically negates a lot of the drag. So whereas a normal rotor, you have an equal opposite drag reaction on one particular pole. What's going on with this is we have two poles going on, because we have the magnets on the stator there, in this rectangular part here. The magnets are conducting through the nanocrystalline core material on the rotor, and then we have a second gap between that and the coil. So we have two gaps. We have the gap between the rotor and the magnet, and we have a gap between the rotor and the coil. So instead of one gap where you'll just get one phase of reaction, we have two phases, and both phases seem to be opposite each other. So when I say opposite, I mean one phase is maybe pulling, the other phase is pushing. So we tend to balance out. Seems to be what's going on with it anyway. The reflector, it basically reflects a magnetic field, so we end up with a situation where the field is basically flipped around, so it accelerates. When I put iron on the side of it, you saw on the actual model, I put a piece of steel right down the middle, down here, and when I put that steel on, it speeds up instead of slowing down, which is back to front, really, what you think would normally happen, but it actually speeds up when you put a piece of steel on here. So that demonstrates there is definitely a relationship going on, which is opposite to what we normally see, right? So yeah, anyway, I just wanted to show you that, because I will show you the test I did with it, but I had some issues because on the down wall, and when I was doing this, and I didn't like, I was going to live stream it, but it ended up with a situation I didn't even know if I was going to do it, to be honest with you. I started to get the segments out, and I thought, well, I'm halfway there now, I might as well just take them out and put the new ones in. So I did. I put the new ones in. I thought, well, I'm curious. I want to see what it does, and I'll see if it's actually twice as much what I was estimating. I was estimating I would probably get 3 volts, but I didn't actually get 3 volts. I got closer to 2 volts, which was only a bit. Was it 2.2 volts or something? It was. It was better than what I expected, better than what it was before, but it wasn't as good as what I expected, and that was because the only difference between these segments is the fact that these have got the 2 in the middle, and on the other segments I did earlier there's a gap, so this bit was a big air gap in the middle there. So the only real difference between these segments, which are wider, is these 2 bits of nanocrystalline in the center. So it only gave me a small improvement, didn't give me a bigger improvement like I was really wanting, but yeah. But I'll try and show you that. I haven't got this thing up to speed right now, it's not even running right now, but I'll try and show you quickly while I'm live. So give me a sec while I turn the power on, because it's not been off on the supercapacitors when you're charging up, so I'll try and charge them up a bit. I'm going to put my RPM meter on as well. It takes a while to get this thing up to speed as well, you know. I don't know if it's going to catch, so I'll just check that first. Oh, it seems to be alright, it doesn't seem to be catching. I'm just going to get this up to speed. I'm going to have to take the camera out the stand, I think. Just a minute, let me just flip cameras again. I need to get the zoom off. If I can get the camera out. So yeah, I've just been feeling really tired lately. I don't know what's going on with me, but I'm just letting it get up to speed. The good news is the RPM is still really good. Oh dear me, let's see, what was that? Looking to see why it pinged on me. See if I can get the camera out of here a minute without breaking my phone stand again. Actually, the easy way is to just pull this and let my camera slide out. Just a minute while I get this out of the phone stand. Come on, out. Right, that's better. Right, I've got the. Give me a sec while I pick it up again. Right. So, and the voltage at the moment is 1.93, and we're still climbing at the moment. So it gets up to about 2 volts eventually, but there's somewhat catching, you can hear it. It's out of balance. I need to rebalance the damn thing. Input current will eventually drop down to... Actually, I'm going to speed this up. I'm just going to flip the switch onto the 20 volt range without changing my variable potentiometers. That way it just gets this thing up to speed quicker. So I'm just going to cheat a bit because I don't want to wait around for another 30 minutes capacity. Yeah, it's at 2 volts right now. RPM. This just makes things a bit faster. And I'll flip the switch back to the 10 volt range. So there we go. We should have reduced our waiting time basically. So I don't know. I may have messed with the potentiometers. I left them set where it was set. So it's at 2 volt, and we're at 1,900 and. Well, I have to let it stabilise while it flattens again, because I overcooked my supercapacitors a bit. Well, didn't really overcook them. I just put more power in than what they normally would get at this voltage, because the voltage I'm running it at is the same voltage as previously, which is what's that? 8.6 volts, 8.5 usually. So that's the volts current. Well, I've stabilised at about 219 milliamps. 219 milliamps, and we're at 1.96 volts AC RMS. So yeah, RPM is at 1886. I'm going to flip current on because I haven't done a current test. Let's put this back onto the current. We're on current now, and we're drawing about 16.5 milliamps. Let's check RPM, see what we lose. Not much at all. Check current. 16.5 milliamps. That's when it's shorted. There is a resistor in the meter, so I mean it's not much point in me sticking a resistor over the output load, because this is how the meter measures current anyway. It has a resistor inside the meter. It just measures the voltage across that resistor inside. And the current input is 224 milliamps. So good as it was. I mean, we don't lose much RPM. There's very little. It takes very little to drag that rotor down. We're stabilised now. It's going back up again. This is the weird thing about this system. It does strange things. Yeah, it's going back up again. Look, and we're still on current. So yeah, output current, sorry, I mean input current. I am getting mixed up here. I'm tired still. Yeah, right. 210, 20, 230 milliamps in input at the moment. Yeah. Anyway, so I'd sort of just show you that. Yeah, there's more. When I add more steel onto the side there, which is what these things are, it actually speeds up. Yeah, so I've got the nanocrystalline on the back there. Yeah, it's slightly out of balance at the moment. I don't know if you can hear it, but it's, yeah, I didn't really balance it properly yesterday when I was feeling groggy. Felt like shit with it basically, so I just it's speeding back up again. Oh well. We're still on current and it's speeding back up. Input current seems to be dropping slowly. Anyway, that video is getting a bit too long. I've already been at it for 30 minutes. I'll turn my meter off. I don't want to run the battery down. I'm going to leave it running for a bit. Yeah. So yeah, I'm kind of thinking about doubling up my rotors. You know, getting 2 rotors, and then which means printing all the stand. You know, the stand that it's on, and new canopies, and the good news is I probably don't need to reprint the stators that hold the magnets, because what I probably would be doing is well, I'd probably have a stator on the other side as well, so I could probably just use the other stator that's here. Could probably just use that stator for the other side, so it'd save me some plastic. Oops, oh, throwing the damn thing on the floor. Now I've got a bearing already in it, so I could basically put this stator on the other side, have 2 rotors. I'd have to print another rotor though, that's the only thing. Yeah, if I could double this up I should, and also make the canopy so they're not quite so big, because the gap, that gap is really big. I didn't realise how big it was. I must have miscalculated when I was doing it. Oh, the vibrations knocked my sensor away. I've got a big gap on my sensor. There we go. It's, as I say, it's out of balance at the moment. That's the speed right now. We're still under load. We're still under current, which is interesting. We are drawing a bit more input current now. More winding copper wire and everything. Well, I don't look forward to doing that, I really don't, but at the end of the day there's only so much wire I can get on that little thing, and if I can close that gap that I was showing you, that 12mm gap between the actual edge of the rotor and the top of the canopy, I should be able to gain a lot more output. It should be even much better. I just didn't realise my gap was that big. I mean, I have issues with it catching, but it's been catching on the side walls of the canopy, not the actual outside perimeter. So yeah, let me know what you think in the comments. I mean, I'm pretty sure I'm going to gain quite a substantial output if I just redesign them canopies. I'm not quite sure what happened there. I miscalculation in one of my dirt moments. Yeah, but yeah, there is a pretty big gap there. Alright, so talk to you later. Bye for now.